In this video, I'll be showing you some simple exponential equations that you can solve by making the bases the same. So your job really is to find a way to make the bases all the same. Okay, here's an example number 1. So you find that this is 2 to the power of x minus 3. Okay, so I can write the right side also to have the same base like this. So I have 2, let's see, 2 to the power of x minus 3. I need to write that 8 to look just like the same base. So 2 to the power of what? That would be 3. So if the bases are exactly the same, see the base is the same, then the exponent must be the same. So what we need to do is just set them equal. So like this, x minus 3 must be equal to 3. And then we can add 3 to both sides. And we will get x equals 6. So in this case, x equals 6. You can test it. If I put 6 here, 6 minus 3, that would be 2 to the power of 3 is 8. So it works. All right. What if you have a situation like this one in which, you know, it's not like the 2 here, there's a 2 on the left and the number, a power of 2 on the right. There is no way to write 4 as a base for 32. So we need to rewrite both sides like this with a base that is common. So it will be 2 to the power of 2 for 4, and then x minus 5, and then 2 to the power of what make 32? That will be 5. Now this is the tricky part a little bit. You see these two, if we follow the rule that if you have a to the power of n to the power of m, you need to multiply these two numbers together. You will multiply this, okay? So it will be a to the power of n times m. So the same thing we're going to do right here. We're going to multiply 2 times x and then 2 times negative 5. Okay, so it will be 2 to the power of 2x minus 10 equals 2 to the power of 5. So we're happy. We have the same base. See the same base, and then the exponent must be equal. So now we're going to set the exponent equal to each other. So with 2x minus 10 equals 5. And then add 10 to both sides. 2x equals 15. And then divide both sides by 2. So x equals 15 over 2. And that is the answer to that. All right. So let's say I have one with a fraction like this. So if I have one with a fraction like this, what I need to do is to write the 1/8. See, this 1/8 is really 1 over 2 to the third power, which you can write with a negative exponent. Remember, when you change the fraction like that, can be converted to a negative exponent, okay? So we're going to write the 1/8 and replace it with 2 to the power of 3. So it will look like this, 2 to the power of negative 3 rather. And then you have 2x minus 3 equals 2 to the power of 4. That's 16. 2 to the power of 4. So now we're going to distribute like I did before. We're going to get this negative going like that. The same negative 3. So negative 3 times 2 is negative 6x. And then negative times negative 3 times negative 3 is plus 9. All right. And now we have the exponent are the same when the bases are the same. So now we're going to go ahead and solve this to the end and write negative 6x plus 9 equals 4. Subtract 9 from both sides. So negative 6x equals negative 5, and then divide by negative 6. And then you will get x equals 5 over 6. And that is the answer to it. X equals 5 over 6. What if you have a number in the front like that? This is what you should never do. Never multiply these two numbers. No. Do not multiply them. Do not do that. So what you would do instead is this number in the front here needs to be taken out by division. We divide it out like that. So it goes away. We need to make the equation to look just like the original one where there's nothing in the front. I'm going to the first one in which there was nothing in the front. See here, there is nothing in the front. It's just the exponential expression, okay? Let me highlight it for you to see that clearly. See, there's nothing in the front. That is your goal. Whenever you see an equation that has something in the front, we need to divide it off. We're going to divide it off like I just did now here. So now I am ready to write the new equation to look like this. It will be 3 to the power of x plus 1 equals 54 divided by 3 is 27. So we're ready now to do it just like we did before. So there's not too much explanation about this anymore. So x plus 1 equals 3. Subtract 1 from both sides, s equals 2. Okay, so what if you have the fraction on the right side like this one? Where is the same? 2 to the power of negative x minus 3 equals 1 over 32 is really 2 to the power of negative 5. And then you can finish it off like that, negative 5. You make the exponent the same, okay, when the base is the same. So you're going to add 3 to both sides. So it will be negative x equals negative 2. And then x equals 2. Now, we're going to apply what you have learned here to logarithm. Okay, here is logarithm like we said in class. So I'm going to write this logarithm, rewrite it like this. I'm looking for a number. I'm going to raise this to 2. This 2 must be raised to some number to get 32. All right, I'm going to call that number x, okay? So 2 to the power of x must be this number 32, okay? So now we're going to say that 2 to the power of x equals 2 to the power of 5. And so x has to be 5. That's how you deal with logarithm when you are using exponential equation to find it, okay? You just rewrite it as 2 to the power of something equals the number. All right, how about when you have a bigger number at the base like this one? It's the same principle. So I will say 27 to the power of something must be 3. All right, so I am going to write this as 3 to the power of 3 to the power of x equals 3 to the power of 1, which I can write as 3 to the power of 3x equals 3 to the power of 1. And then I can divide, I can set the exponent the same whenever the base is all the same, okay? So 3x equals 1, x equals 1/3. All right? Here is another one that may be a little bit puzzling, but it's the same idea. I'm going to use this base. 1/4 to the power of something must be equal to 64. And now I can actually write this as 1/4 to the power of x is something as, let me just write it as 4 to the power of negative 1. 4 to the power of negative 1 to the power of x is 4 to the power of 3. So now 4 to the power of negative x, when you multiply these two together, you get negative x equals 4 to the power of 3. So negative x equals 3, x equals negative 3. I'll do 2 more that might be puzzling. There is another one over here. So I have 1 to the 16th to the power of x equals 2 to the, equals 2. Okay, so this will be 2 to the power of negative 4 to the power of x equals 2. So 2 to the power of negative 4x equals 2. And now we can just set the exponent together. Negative 4x equals 1, and then x equals 1 over negative 4. All right, I think I have time to do one more. This last one over here. No, I'll do this one because both are fractions. 1/3 to 1 power will give me 1 over 81. I just make them both 3 to the power of negative 1 to the power of x is 3 to the power of negative 4. Negative x equals negative 4, x equals 4. Okay, so the last one is this. I have 1/5 to the power of something equals 25. So it will be 5 to the power of negative 1 to the power of x is 5 to the power of 2. And then you have 5 to the power of negative x. When you multiply these two together, equals 5 to the power of 2. Then I can say negative x equals 2. You can see that I'm rushing a little bit. This is because my class is about starting. If you still have any more questions, come talk to me during tutorials.